All right, so we are on page 42 right now, and we're going to start with a review problem. The picture below shows two desks viewed from above, whose corresponding sides are proportional. The numbers indicate the length and width of the desks in feet. We need to find our missing measure, so let's locate that. First off, let's make this screen big. Here we go. So looking here, actually, notice here I have x feet, and I'm trying to find that missing measure here. So we identified the kind of problem, or discover the problem type. It's not a unit rate. There's nothing about a unit rate finding per one. We're trying to find comparing equivalent fractions. We haven't learned cross multiplication yet. However, that is an option as well. So right now we're focusing on equivalent fractions. Okay, so let's fill in. We've got our large desk compared to our small desk. So if I have my x feet here, let's say this is my large, and I'm comparing my large again. So here's my if. And let's compare my large x feet to this side here. 16 feet is fine. Okay, so I'm looking from this side to this side, and this side is proportional to this side. So now we match up our sides. So if I'm using this side first for my small one, I need to also compare that side first. Okay, so look at this side to this side. Well, that's going to be 4 feet. Then looking from this side, 16, comparing it to this side, that's going to be 8. Okay, so now looking at equivalent fractions, we could go horizontal or we could go vertical. I'm going to go vertical because we're looking proportionally. 8 divided by 2 gives me 4. Oops, that's supposed to be a 2. So 16 divided by 2 should give me 8 feet. So my total feet here should be 8 feet, which looks about accurate. This looks about double that. All right, next slide. So here are your solutions to lesson 7. If you want to pause the video, you can. Otherwise, this is what you had to do. So now we're going to talk about scale drawing problems, and we're actually going to get into drawing things a little bit more this week, and we're going to talk about how scale drawing problems are solved using proportions. So here's some just basic information that you need to know. Similar figures. They have the same shape, but not necessarily the same size. Scale drawings that represent real objects that are too small or too large to be drawn at an actual size. So for example, architects draw buildings that represent a larger building, okay, or maps. Think about maps, okay? All right, so the scale of a drawing is a ratio of the size of the drawing to the actual size of the object. So you're comparing the size of the drawing to the actual size. And the scale factor is that value of the ratio. Remember that? The value of the ratio. So when you actually divide. Okay. So remember that a scale drawing is a type of proportion problem. Okay. So now we're on example 1, which is on page 43. So here we have a scale model of the Tower Bridge in London that shows a scale of 1 foot is equal to 200 feet. So here's a ratio that is really important for us. We're trying to find the scale factor that indicates how much smaller the building is than the actual bridge. So basically what we're going to do is we're going to have our scale in here, which we know is 1 foot divided by 200, 200, which is going to be 1/200th, or you can find a calculator and figure that out. So it's 1/200th the size, okay? Now, the scale factor that indicates how much bigger the bridge is than the model, we start with our larger model, or we just start with the 200 feet, the larger one. So it's going to be 200 divided by 1, which means our bridge is 200 times larger than the model. Okay. Page 44. We need to find the scale factor indicating how much bigger an actual door is than how it is drawn on a blueprint, if 1 inch represents 2 feet on the blueprint. So we have a door. Here's my little door, and it's drawn on a piece of paper for a blueprint, for maybe a map. And 1 inch, maybe this represents 1 inch in real life on a map, means that's going to be 2 feet. So what we're trying to figure out is a scale factor indicating how much bigger it is. So the first thing that we need to do is actually make sure our units are the same. So I'm going to just change everything to inches. So 1 inch is equal to 2 feet. Well, let's change it so that inches match, because I think that will be a lot easier for us to see that scale factor. So I'm going to change everything to inches. 1 foot I know is 12 inches. 2 feet then is 24 inches. So 1 inch, my ratio then is going to be 1 inch compared to 24 inches. So if I'm trying to figure out the actual bigger scale factor, how much bigger it is, I take 24, divide by 1, which gives me a scale factor of 24. And I'm not going to lie, this is really hard to draw on my computer, but I hope that this makes sense. So the door is actually 24 times bigger than the blueprint. Make sure you write in your answer right here. All right, the scale on a map of Minnesota indicates that 1 centimeter represents 5 kilometers. What is the scale factor that indicates how much bigger the state of Minnesota is than how it is drawn on the map? Note, 1 kilometer equals 100,000 centimeters. So we are going to change, first off, kilometers into centimeters. So 5 kilometers, well, if 1 kilometer is 100,000, 5 kilometers is going to be 500,000 centimeters. So 1 centimeter represents this 500,000 centimeters. Okay? So if you fill it in here, see what you get, and I will let you know the answer. Pause the video right now, fill it out, see if you can find your scale factor. Hopefully you pause the video. Your answer is actually going to be 500,000 times larger. So you need to fill this out and say times larger or bigger. All right, so now we're actually going to get into some proportion problems. So here we have Walt Disney World, and we're looking at the scale is 1 inch of the map represents 3 miles in the actual theme park. What is the actual distance between Magic Kingdom and Animal Kingdom when it is 4 inches on the map? Okay, so in order to do this, we need to fill in our if then. So our if was, we have a scale factor. So we were looking at 1 inch, if 1 inch represents 3 miles, then, and remember, we want to make sure our inches and our miles are matching. This one should be inches, so this should be the map, and this should be in actual real life. Okay, so again, this here is my map, this here is actual real life. So 1 inch represents 3 miles. We're trying to figure out what 4 inches represents. Okay? So again, we can look at our relationships. I can look vertically or I can look horizontally. I'm going to look vertically because it's proportional. I notice 1 times 3 gives me 3 miles. So if I do 4 times 3, I should get my answer. So 4 inches is actually going to represent 12 miles. So make sure again you fill in your answer down here. Okay. All right, last problem that we're going to do. I'm going to start it, you're going to finish it. On the blueprint of a garage that Taylor is designing, each square has a side length of 1 inch. What is the actual width of the garage? Write and solve a proportion using the scale. So here we have our scale. If, that's going to be my if 1 inch is equal to 2 feet, we need to figure out the actual width here. So we're going to have to actually count out some of those pieces here. So I will start it off. 1 inch is equal to 2 feet. You need to figure out by counting how many inches and then figure out how many feet. So count these little squares here and that should tell you how many inches to figure out your width. Your assignment will be lesson 8 and that is in Schoology.